Hello and welcome to my YouTube channel. Today I'll be talking about another method, and this time is going to be mesh current method, or also referred to as loop current method. Right? Now, when it comes to applying mesh current method, right, we are going to be following some specific steps, right? These steps allow us to what? To use mesh current efficiently. And mesh current method is actually based on the idea that by assigning current to meshes in the circuit diagram, we can later apply Kirchhoff's voltage law and the Kirchhoff's current law that will allow us to determine the current flowing through resistors in the circuit diagram. Right? The objective is to find the current that are passing through resistors in the circuit diagram, and by using mesh current method, we can achieve that goal. Now, let's start with the steps. So the first step here, step 1, we have mesh currents. Here, what that means that you assign current to the meshes in the circuit diagram, and a mesh is referred to as an independent loop. So it's a loop that does not contain any other loop inside it. So if you look at this circuit diagram, for example, this is a mesh. Because this is a loop, there's no other loop in it. Then this one too is a mesh. You don't have any other loop within it. But you take a look at the third loop, this one, if I go just in a closed circuit, you can see that will be loop 3, but that loop 3 is not a mesh. Why? Because within loop 3, you have loop 1 and 2 is inside loop 3. So loop 3 is not a mesh. So here we have two meshes, all right? Loop 1 and 2. Now you assign current to the mesh, to each of these mesh. So I'm going to assign I1 here, small letter I1, as the loop current or the mesh current there, meaning all these resistors that are in loop 1, the mesh current is what? Passing through all the resistors. So I have here loop 1, 2 resistors, R2 and R1. So you can see I have my mesh current is passing through what? R2 and then R1 as well. Now we assign mesh current I2 to mesh 2. So in that one too, we get all the current in that very loop. The mesh current I2 is flowing through all the current in that loop as well. So we have here I2 goes through R3, R4, and then R2. Right? Yeah. Now that we've done this, we've assigned the mesh current. And then here, after that, step 2, you indicate polarities on the resistors in the circuit diagram based on the direction of the current. So based on the demand of the mesh current that we have indicated, then I have to indicate the polarities. So you can see here the mesh current. I'm making sure all the mesh current are going in this direction, right? This and this direction, they are all going clockwise. So if we are now going to indicate the polarities on the resistors based on the direction of the current. So you can see here, mesh current 1 is going down. So here we have plus minus, where the current is, we get negative there. Then we come here, it enters the first terminal of R1, the current enters the first terminal of R1, so we get plus. When the current leaves, we get negative. So when it comes to mesh 2, that one too, we have, again, I2 is passing through all the resistors in that very loop. So we have mesh current. This one becomes positive. Going in this direction, we have the positive, negative. And then when it comes to R2, here is positive, negative. So you can see R2 is having two polarities. One from I1, mesh current I1, and then the other one from mesh current I2, because both of these current are passing through R2. Now the third step, apply Kirchhoff's voltage law to the meshes. So here we go ahead, and then for each mesh, which is just a loop here, our independent loops that we have 2 of them. We apply Kirchhoff's voltage law to each of these meshes. So we start with mesh 1 or loop 1. Here, again, we choose a direction. So here I'm going to go clockwise direction. So starting from the first voltage, you can see here is minus, plus. You have minus, plus there. So that will be what? Rise. We are starting from this. That will be rise. So it's positive. Now when we come to R2, there are two currents actually passing through R2. We have I1 and then what? I2. Because we are in loop 2, so we consider I1 to be the dominant what? Current. So we take I1 minus I2, then times the resistance, which is R2 then. So that will give us the voltage across the resistor. So we have it here, R2 minus R2 is equals to I2 minus I2. Then here we come here, I1 passes through R1, so we have also draw plus to minus. We get here to minus R1, I2. Well, we go ahead and apply Kirchhoff's voltage law to mesh 2 as well. That one, too, we start from a voltage, from a resistor, then we go at a clockwise direction. So here, this here, I'm going clockwise. So you can see this one plus to minus is going to be dropped. Here I'm now in loop 2. So loop 2 is about the dominant current there. So I have I2 minus I1 times 1 minus R2. Then we come here, plus to minus, that is drop. Here plus minus drop. So they are all drops as well. So we can just simplify to what? Minus I2 into R3 plus R4 because they are all in series, R3 and R4 in the series. Then equals to 0. That gives us equation 2. Now you solve these two equations, right? Because we have two measures. That will give you what? We have to vary in that regard. Then that will give you I1 and I2, right? So after this, you then come to your circuit diagram and indicate the what? The branch current. But here the trick is that when you are indicating, you make sure that the direction of what? Your current follow the direction of what? Your mesh current. So I have my I1, which is the branch current or the real current. See that it's also, I make sure it's also going in this direction. I3 is also in the direction as mesh current I2, right? And then the problem is now I2. We have to try and calculate I2 because we know I2 here, I1 goes through it and as well as what? I2. Now that we've indicated, so you can come and then say, okay, based on what the circuit diagram I have, you can see for this branch that I have, this only what mesh current I1 there. So that means I can write I1 equals to what? Mesh current I1, my right current I1, or branch current I1 is equals to what? Mesh current I1. The same thing for I3 is only what? Mesh current I2 then. So I3 is equals to what? I2. Now that we've done this, I've gotten I1 and I3 for the branch currents, or the, you can say the real currents. Then a level of I2. So here we then come and apply Kirchhoff's current law at node A. So which is what? The fifth step, right? Then with this, we have our node A here. See the sum of current entering should be equal to the sum of current leaving. That gives us what? I1 will be equals to what? I2 plus I3, which is CF. And then you make I2 the subject, then you get I2 equals I1 minus I3. So this is how you use mesh current method. Then if this is your first time of watching a video on this channel, do not forget to subscribe and then comment below if you have any question. So this is another example. We have a circuit diagram. And when you come to this circuit diagram, you can place that we have three meshes. We have 1, 2, and 3. So we have 3 dependent meshes. Then we are going to follow the rules, right, the steps again and see what we are going to get after. So step 1, meaning you indicate the meshes, the mesh currents in the circuit diagram, right? So we have here, I have I1, mesh current I1, mesh current I2, and then mesh and I3. Those are my mesh currents. Then second step, indicate the polarities according to the direction of the currents. So I have mesh currents I1. So for mesh 1, mesh current I1 is passing through all the resistors in that mesh, in that loop. So we have here, where we count plus minus. So this is also a resistor plus minus. Then we do the same thing for I2. It's going through all the resistors in mesh 2. So we have here plus minus. So it enters here plus minus, here plus minus, and here plus minus. Then we do for the last one, mesh current I3. For mesh 3, we have plus minus. Then we have here plus minus on the resistor, this resistor as well. Now that I've done this, the next step is now going to what? Step 3, apply Kirchhoff voltage law to each of these meshes in the circuit diagram. I have the first one, mesh 1. So here I'm going to go clockwise direction. So if I'm going clockwise direction, here's minus to plus. That is what rise. So I have positive V1. Then here is what drop. So we have R1 times I. Then I'll come here to R5. You can see R5 here. Mesh current I1 is what passing through it, as well as what mesh current I2. So because we are in loop 1 current, or the mesh current here is the dominant current. So we take I1 minus I2 times the resistance, which is 5. So it's a drop. So we have minus here. And then we come here, there's a voltage source here. Here, based on the polarity, we have plus, which is also drop. So we have minus V2 equals to 0. This is for give us equation 1. Then we go and apply Kirchhoff voltage law to mesh 2. Mesh 2, I'm going to start from what? Resistor R5. Then the voltage across there. So here you can see I have mesh current I2 is passing through it. So this is a drop, plus minus is drop. So I have I2 minus I1 because I'm now in what? Mesh 2. So the mesh current there, which is I2, is a dominant current. So we have I2 minus I1. Then here is a drop. So we have minus I2 times I2. Then we come here. Here, again, you can see R4 here. Mesh current I2 is going through it, as well as what mesh current I3. Again, we are in loop 2, so mesh current I2 is a dominant current, so we get minus R4, I2 minus R3. Then we come here. Now, from there, we come to this point. You can see here, we have a voltage source, plus minus is drop, so we have minus VR. Then here we come here. Now it's what? Minus to plus, which is what? Right. So we get here to plus V2 equals to 0. Now this gives us equation 2. Now when it comes to equation 3, we obtain it by what? Applying Kirchhoff voltage law to mesh 3. So this one too, we are starting this time from what? The voltage source here, V3. So plus minus is what? Rise. So we have V3 minus. You can see here plus to minus here is drop. So we have minus. We are now in what? Loop 3. So loop mesh 3 current here is the what? Dominant current. So we have I3 minus I2. Then we come here plus minus is drop. So we have minus R3 times I3. Then here plus to minus become drop. So minus V4 equals to 0. This gives us what? Equation 3. Then you solve for the currents, you get mesh current I1, I2, I3. Once you are done, you come and indicate the right currents, right? So I have them here, I1, I2, I3, I5, and then I4. So when it comes to getting I1, you can see here it's just the only current in that branch. So I1 is equals to mesh current I1. When it comes to what? I2 here, where current I2. So you can see here for this part here branch here, we have 2 min equals I3. But when it comes here, you can see here, again, we have a node. We can apply the sign Kirchhoff current law, which is what? Step 5, right? So that was step 5 to find the current, meaning I3 here. So if here, I1 is entering I3 and then I2 are leaving. So I1 goes I2 plus I3. But we know I1 to be mesh current I1, I2 mesh current I2. So I3 become I1 minus I2. So the same thing here, we come to this loop 2 as well. The node here as well. We apply Kirchhoff current law at node C. So at this node, you can see here, I2 is entering, I4 is leaving, as well as at 5. So we have I2 being equals to I4 plus I5. So again, we already know this to one mesh current I2. And then when you look at I4 here, could what? Mesh current what? I3, then which is here. Then I5 gets what? I2 minus I4. So this is how you use mesh current method. If you are new to this channel, make sure you subscribe. If there's any question, you comment below so that I'll look at it and try to answer it in the next video. Bye-bye.